Have you ever wondered how seawater is transformed into the drinking water that reaches our homes? In this video, we are going to embark on a fascinating journey to discover every detail of this innovative process. From the collection of salt water on the coast, through rigorous filtering and reverse osmosis processes, to the final adjustment that turns it into a pure, balanced liquid. We will show you step by step how technology and science come together to transform the ocean into a source of life. Step 1. Collection and pretreatment. It all begins on the coast, where a strategic location is carefully chosen to collect seawater. Imagine an extensive stretch of coastline surrounded by the vast ocean and protected by open intakes that ensure a constant flow of salt water. The collection is carried out through large water intakes located several hundred meters from the shore to ensure that the water reaching the plant is of the best possible quality and that environmental impact is minimized. The extraction process is as fascinating as it is vital. A large tube about 63 centimeters in diameter is responsible for sucking in around 15 million liters of water per day. However, not everything that comes with seawater is desirable. The ocean brings with it tiny organisms, from mollusks and jellyfish to crabs and small fish, that must be carefully filtered out to prevent these unwelcome visitors from entering the process. Giant grates are used to sieve out any object with a diameter greater than 4 or 5 millimeters. Once this first filter is passed, the water still contains sediment particles and suspended matter. Here, a natural process comes into play: filtration. The water passes through tanks with sand beds, where, thanks to the action of gravity, solid particles remain behind, trapped in the tiny spaces between the grains. It's like letting a drink settle so that the impurities can deposit at the bottom. But the process doesn't end there. There are still microscopic particles that could affect the water quality. To resolve this, the plant adds 2 essential elements: sodium hypochlorite, which acts as a disinfectant, and iron chloride, a coagulant that binds the particles together to form larger clumps. These small lumps sink easily, leaving the water considerably cleaner. At this point, the water has already undergone a first pre-treatment that prepares it for the following steps, in which almost all the salt and other impurities will be removed. Step 2. Advanced pre-treatment. Although many impurities have been removed, the water still contains tiny particles that cannot be seen with the naked eye. This is where technology and science join forces in an advanced filtration process. The water is directed to a series of basins where a constant stream of air makes the sand rotate, enhancing its ability to filter even the finest particles. It's like a mini cyclone where the sand acts as a guardian, capturing any microscopic dirt that may have remained. Then the clean water is stored in giant 500,000-liter tanks to keep it ready for the crucial desalination process. At this point, the water transformation approaches its most spectacular phase. The removal of salt, an element so intrinsic to seawater, naturally adheres to the water molecules, so separating these two components requires a very specific and technically complex process. Before reaching the reverse osmosis stage, it is essential to ensure that the water is as clean as possible, eliminating even the tiniest particles. This pre-treatment is vital to protect the equipment and ensure that the semipermeable membrane, which we will see next, does not become clogged. The coordination between filtration, chemical pre-treatment, and temporary storage is the pillar upon which the success of desalination rests, and is a clear demonstration of how modern technology adapts to solve major environmental challenges. Step 3. Reverse osmosis. Now comes the moment that many consider the magic trick. In this process, reverse osmosis, imagine that the salt water that has undergone rigorous pre-treatment now faces a real test of pressure. The key to separating the salt and other unwanted minerals from the water is to apply enormous pressure, up to 60 bars. which is equivalent to 60 times the normal atmospheric pressure on Earth. In this process, centrifugal pumps are used to raise the water pressure to very high levels. Once this pressure is reached, the water is channeled through units equipped with semipermeable membranes. These membranes are crucial parts of the system, as they function as an extremely fine filter. Only the much smaller water molecules manage to pass through these minuscule pores, while the salts and other minerals are left behind. The design of these membranes is truly astonishing. They are made of plastic sheets with pores approximately 1/10 the thickness of a human hair. This ensures that almost 99.8% of the salt is removed from the water. As the water passes through these membranes, it comes out purified, while the salt concentrates in a residual stream known as brine. The functioning of reverse osmosis is an amazing example of applied engineering in physics. The applied pressure is crucial, and every part of the system works together to ensure that the water is separated from its impurities. It is in this step that the true transformation occurs, from being a liquid loaded with salt and minerals to becoming almost pure water, ready for the subsequent processes of adjustment and quality control. Step 4. pH adjustment and remineralization. After reverse osmosis, the water is already considerably free of salts and other contaminants. However, the process doesn't end there. Sometimes, such intensive purification can alter the water's pH, leaving it in a state that is not optimal for human consumption. To remedy this, the pH is adjusted by carefully adding acids until the desired level is reached. This adjustment is fundamental so that the water is not only safe, but also pleasant to taste. There is another detail we cannot overlook. Desalinated water, having lost much of its natural minerals, may lack certain essential elements for health. To improve its taste and quality, a process known as remineralization is added. During this phase, small amounts of mineral salts such as calcium and magnesium are incorporated. These minerals not only balance the water's mineral profile, but also provide health benefits by helping regulate acidity and strengthen the skeletal system, among other advantages. This phase is a precise touch that transforms the purified water into a final product ready to drink. It is in stage where science and care come together to ensure that every drop of water is not only clean, but also has that something that makes it refreshing and healthy. Step 5. Disinfection, quality control, and waste management. Although the water has already undergone a rigorous process of filtration and separation, the final challenge is to ensure that no microorganisms remain that could affect the health of those who consume it. For this reason, a final disinfection stage is carried out by adding chlorine, a powerful agent that eliminates any residual bacteria or microorganisms. This measure is extremely important to prevent any risk and to ensure that even after being intensively treated, the water remains absolutely safe. The disinfection process is as meticulous as everything that has come before. Exhaustive tests are conducted, including analyses of turbidity, dissolved solids, heavy metals, and the presence of disinfectant residues. A computer controls every parameter to ensure that the water meets the strictest standards established by regulatory authorities. Each analysis is a guarantee of quality and a commitment to public health, demonstrating that technology and science work together to offer us such a vital resource. But it's not just about preparing the water for consumption. It's also about responsibly managing the waste generated. The salt and other solids that are removed from the system are not irresponsibly discarded. Instead, they are treated and diluted in the power plant before being returned to the sea, so as not to alter the natural salt level. This proper waste management is fundamental to preserving environmental balance and ensuring that the desalination process is truly sustainable. Step 6. Distribution. Once the water has been completely treated and has passed through every phase of the process, the final and perhaps most gratifying step arrives: distribution. The water, now transformed into an almost crystalline and perfectly balanced liquid, undergoes a final quality control to ensure that it meets all the standards. precise analyses of essential parameters are conducted to make sure that the chemical composition is ideal for human consumption. This control is carried out automatically and supervised by specialized technicians who monitor each of the 10,000 elements and membranes that have collaborated in the process. It is a team effort that guarantees the reliability of the water reaching our homes. Once approved, the water is distributed through an extensive network of pipes that run through cities and towns, bringing life and health to over 300 million people worldwide. Every step of this journey, from the collection in the ocean to the moment the water reaches our taps, is the result of a masterful combination of engineering, science, and environmental commitment. The desalination plant is not just a water factory, it is a true testament to human ingenuity and our ability to transform natural resources into solutions that improve our quality of life. Thank you for joining me on this journey through the fascinating world of desalination. If you found this explanation useful, don't forget to subscribe and like it. Will you continue drinking water after seeing the desalination process? Leave your answer in the comments.